every song you have ever heard, from pop music to classic music to electronic music or any type of music, lives inside a universe where we can mix melodies, we can change their speed, their volume, and we always get into another melody inside the same universe. Mathematicians call this universe a vector space. Imagine a vector space as a toolbox of objects where two rules always work. Rule 1, you can add two objects together, and rule 2, you can multiply any objects by a number, and we call this number a scalar. We could imagine this universe as music where the objects are melodies inside this musical universe. Our scalars could be volume changes or tempo changes of the melodies. So if you add two melodies, you get another melody, and if you make a melody twice as fast or twice as slow, you still have a melody inside the same universe of melodies. The space of all these melodies is our vector space. So now let's build an example using a musical instrument. We are going to use a violin so we can hear this space of melodies, our vector space of melodies. So let's imagine our toolbox that we know in this example that our toolbox is our musical universe of melodies, contains all the melodies you can play using just three notes. And let's fix these notes as C, E, and G, for example. Every melody is like a combination of these notes over time. So let's play now two melodies that we are going to call from now as melody 1 and melody 2. So let's play melody 1. And now let's play melody 2. If we add melody 1 and melody 2, which in music is like playing them together, we still get a new melody. And it's very important that in our case that it's a melody, a new melody that still uses the same three notes defined previously in our musical space of melodies: C, E, and G. What I mean is that we are still inside the same universe of these three notes: C, E, and G. Now let's build an example that uses the concept of scalars in vector space. In mathematics, multiplying a vector by a scalar stretches it or shrinks it. In music, that could mean if we are talking about volume, you are multiplying. If you are multiplying by 2, it means that you are multiplying the louder the loud of the melody by 2, so the melody sounds louder. And if we are talking about tempo, if you multiply by zero point 0.5, you are slowing it down. You are slowing the speed of the melody by half of the initial time, by the initial speed. Algebra terms, each note is like a basis vector. Each melody we compose inside this space of melodies is a linear combination of these basis vectors. And here is the magic. No matter how you stretch it or you shrink it, you are still inside the same universe of our melodies. We never leave our vector space. So now let's imagine our nodes as dimensions. So the more nodes we have, the bigger our possibilities as nodes as toolbox for composing melodies. So with just three notes, as in the beginning of the example, with the notes C, E, and G, you can make a few nice melodies. But if you open the door and you now have 12 musical notes, you can compose much more melodies. You have much more possibilities. So in summary, we could think about using a vector space to represent a universe where we are working when it makes sense to use combination and scaling inside this universe. Okay, now that we understood what is a vector space, we can see that they could be very useful for a lot of situations. For example, a vector space could be images on your phone, the motion of your objects while you are studying a physical phenomenon, for example, or it could be data in machine learning models. That's all for today. Hope you got the idea of what is a vector space, and don't forget to hit the like button if you like the video, and also don't forget to subscribe to the channel so you can know when I upload the next videos. See you guys in the next video. Bye.